Welcome to this TMDL public meeting for Hickory Grove Lake. My name is Jeff Burkus. I'm the program lead for the TMDL program at the Iowa Department of Natural Resources. You're going to be hearing from Jim Hallmark in a little bit. He is the project lead for Hickory Grove Lake. But I wanted to start off and do a couple of things up top to help kind of put Jim's presentation into context. And the first thing that I wanted to talk about was the public notice period. So we are currently in the public notice period for this particular project, and that public notice period ends on February 15th. And what that means is if you would like to put in an official public comment, you'll need to send that to me. My email address is listed there. That's jeff.burkus@dnr.iowa.gov. Those need to be into my virtual inbox by the end of business on February 15th. If you just have a more technical question or wanted to follow up on something that you saw in the presentation or something that you read in the document that can be found on our website, go ahead and reach out to Jim. His email address is james.hallmark@dnr.iowa.gov. So I'm going to just go through a few slides and cover a few things that I think are important to understand before we get to Jim's part of the presentation. So a couple of terms that are really important for our work. The first one that we have is watershed. And watershed is the area of land that drains to a specific water body that we're talking about. And so today we're talking about Hickory Grove Lake, and that is depicted here in this map that we have in the blue. That is a map of Hickory Grove Lake. Now, what we have here though is the watershed map. So this red outline of all of this land area, this is the watershed for Hickory Grove. The way that I like to think about it is that if we get a rainstorm and a drop of rain falls inside of this red outlined area, it's going to eventually find its way into a stream and right directly into the lake. If it falls outside of that red outline, it's going to go somewhere else. It's going to go to a different watershed. And so watersheds can be all different scales. They can be big scales like the Mississippi River, or they can be something at a smaller scale like Hickory Grove Lake. So when we refer to this project, we're really concerned with everything that's going on inside of this red outline, because that is what impacts the water quality at Hickory Grove Lake. A couple of notes about the maps that you'll see, not only on this presentation today, but in the document, if you're going to take a look at the document, is that we try to have some pointers here for all of our maps. The first is in this upper right-hand corner is a little inset map of the state of Iowa with its 99 counties. And you see this red dot here in the middle, that indicates where we're at in the state. And down in the lower left-hand corner, you have a legend that's going to give you some indications of what we're talking about with the map here. So the red outline is the watershed. We already talked about the blue being the lake itself. This kind of gold dashed line outline is the parkland that's around the lake. And you have roads in black and streams here in this blue color. And we also have a scale down in the corner so you can kind of get an idea of how big of an area we're talking about. All of our maps are going to contain that type of information for you. The last piece of information that you'll look for is we'll always have a compass rose on our maps so that you can get your bearings and figure out which way is north. Again, we're using the same map here with the next slide. So this outline here is the watersheds. This is what we're concerned with, but we've changed the interior colors here. So let's go look at what the legend is. Okay, we're looking at land use, and we can see we've got farmsteads are in this red. Okay, so those are going to be the farmstead areas. What's this big area here that's yellow with the crosshatch? You go down here, you find it, row crops. Okay, so anytime we come across the map, that's what we have for you. But it's all going to be with regards to whatever's in that watershed outline, because that's what we're most concerned with. We'll sometimes zoom in a little bit on the lake if we want to show features that are happening inside of that park area and inside of the lake. This one, Jim's going to talk about where we information, which is here indicated here with this little disc, red disc here. And so sometimes you'll see us zoom in a little bit on the map, but you'll still have that that red outline or that outline of the watershed in all of our maps too, so that you get an idea of what we're concerned with. So that's watershed. And the next term that I want to cover is impairment, something that you'll hear a lot or see a lot. Basically, any time that we're talking about an impairment, what we're referring to is something that's not meeting our water quality expectations. So this can be a lot of things. Jim's going to talk about what specifically the impairment is for Hickory Grove Lake, but anytime we are working in any watershed across the state, that's why we're here. That this program is designed to try to figure out what's going on in the water body where it's not meeting expectations. And so that's all that word stands for, is that there's something that's wrong with the lake based on what our expectations are for that lake or stream if we're working in streams. The next terms, point and non-point source pollution. And so basically, we don't have to worry about point source pollution in this particular project. Jim will talk about that a little bit more. The way that I like to think about point source pollution is that it's covered under a permit that the department would issue. And so we see that a lot with, say, wastewater treatment plants or industrial facilities that get issued a permit that allows them to put water into the waters of the state that may contain a pollutant of concern. We don't have any of that in this particular watershed, so we don't have to worry about it. Non-point means everything that's not permitted that would contain that type of pollution. And that's what we're most concerned with in this lake, is that we're having too much of that non-point source pollution that's coming in. Jim's going to get into some specific ideas, but I think that the main thing to take away about non-point pollution is that it is not permitted discharges. It just happens through various courses to get itself into the lake. And then finally, I wanted to cover the term Tmdl. We already had it on the original slide, as my title is the Tmdl program lead. Jim's the Tmdl project lead. And so what does that stand for? So the acronym stands for total maximum daily load. And those words are very important to our work. And I found this picture a long time ago when I started working, and I thought it really helped me understand what it was that we were trying to do. And so if you see this pack mule here and the cart that's, humorously packed way too much and has him up in the air, imagine that there were no boxes on that cart, and that donkey could run around all day with that cart on his back, without really any issue. Now, as we start to add boxes to the back of that cart, it gets harder and harder for that animal to be able to pull that cart around, to the point where he's not going to be able to move it at all, and to this point where it's so much weight that it actually flips him up in the air. And if we think about this with a water body like a lake, and the boxes being pollutant, we can put a box or two or three or maybe even four boxes onto that lake of pollution, and it's going to be fine. It's still going to meet our expectations. There's an amount of natural ability for a water body to be able to assimilate, is what we call it, but basically handle a certain amount of pollution and not violate any sort of expectations that we expect out of that particular water body. But if we put too many boxes of pollution into the lake, we're going to start seeing problems. And so our goal with the total maximum daily load document and the program is that we're trying to figure out how many boxes do we need to take off. How many boxes of pollution do we need to take out of the lake for it to start to meet expectations again? So it's a lot of math that Jim's going to get into about that, but that's basically the idea. Now, the document itself is going to contain all of that mathematical work, that total maximum daily load work. That's really located in Chapter 3. Chapter 4 is the implementation plan. The implementation plan is not prescriptive, but rather it's a suite of activities that, given the literature and the experience that we have with our partners, these are practices that we believe could be used and implemented at the local level to create positive change towards water quality in this watershed. And so that plan is in Chapter 4. Again, not prescriptive, but something that is there for the individual decision makers to consider when they're trying to create a plan. Those two things together, Chapters 3 and 4, we consider those the major elements that create what we call a water quality improvement plan. So you may see that term on the front of the document and wonder what that means. What we feel that means is not only the Tmdl numbers, but also the information to help start planning process. So that's what the water quality improvement plan is. Sometimes I refer to the document as a Tmdl. You may hear that sometimes as well. They're somewhat interchangeable, but those are what those terms mean. And then I wanted to just show one of the charts that Jim is going to show. And I think this is an important point. Anytime that you're in a presentation or that you're reading a paper like this and you see charts, we're trying to convey a lot of different information with what we're doing. And the benefit of a recorded presentation like this is that if it doesn't make sense the first time, you can hit pause, you can continue to look at the graph or the map to make sure that you get it before you move on, or just hit back 30 seconds or 2 minutes and restart the presentation from a point that that slide starts. And that'll be a nice little tool to help do this. And we work in this stuff every day, and we definitely need to do that from time to time too, to make sure that we're getting all the information. And so Jim's going to talk about this more in detail, but when I see something like this, I'm always going to look at what are they trying to show me with this information, and I'm going to look at these axes here. So this is something called Tsi values that Jim will explain. Okay, down here is time. Okay, so these little points are different colors and shapes. That relates up here to the key. And so I can start to get an idea that, this in 2010, this purple box means TSITP. Okay, what does that mean? Again, Jim will get into that more, but that data point is trying to tell me that value in that year corresponded right here. And over time, we're seeing a trend here. So again, Jim's going to walk you through that and explain it, but anytime I see something like this, I'm going to make sure that I understand what the scales are telling me, what the axes are telling me, what the points are telling me. So that's just a little note before we go. And next up, we'll have Jim take us home.
Thanks, Jeff, for the introduction. As he mentioned, my name is Jim Hallmark, and I'm the project lead for this water quality improvement plan for Hickory Grove Lake. I've, on this slide here, just kind of outlined the things that I plan on talking about in my portion of the presentation. The water quality improvement plan, what it is, and the components and elements of it. We're going to talk a real brief description about Hickory Grove Lake and the watershed itself. We're going to talk about water quality assessment, how we determine a lake is impaired, how we go about doing that, and then we're going to talk about our Tmdl development. As Jeff had mentioned, it's a mathematical equation, how we develop the math and to come up with that maximum daily load. And then we're going to talk just real briefly again about implementation planning, some things that we can do moving forward. Okay, so for a water quality improvement plan, the first step that we take is to monitor and assess a water body. That entails us collecting samples and doing some analysis on those samples that we've collected. Then, when we do a draft water quality improvement plan, and that's kind of where we are right now. We've worked up this water quality improvement plan, drafted it up, and within this water quality improvement plan, we talk about and determine our potential pollutants and their sources and where they're coming from. We determine that total maximum daily load and the calculations to determine that. And then we have an implementation plan where we list potential solutions to the problem, how we improve the water quality in the watershed. The next step is a public meeting, and that includes this public presentation that we're working on and presenting today. The public meeting also would include a public comment period where we ask the public to review and comment on the water quality improvement plan document itself. And then the last part of it is encouraging local involvement. We find a greater success when with local participation, from local agencies or the people that live within the watershed. It also, we look at implementation of certain strategies and practices that can help, and then we'll continue to monitor the water body to determine or measure the performance of any strategies and best management practices that that are implemented within the watershed. So a real brief discussion on the lake itself. The lake is located in Story County, and just south and in between the cities of Nevada and Colo. The surface area of the lake is 100 acres, and put that in perspective, a football field is roughly an acre. So has the surface area of 101 football fields. Okay, so the watershed itself, Jeff talked about that a little bit. The watershed itself has a drainage area of approximately 4,037 acres. And the lake is located within the Hickory Grove Park, which has an area of about 445 acres. Hickory Grove Park is owned and maintained and operated by Story County. We look at the land use within the watershed. It's pretty much strictly row crop, with 85% of the land as row crop. That would be either corn or soybeans, but a very large percentage of the land is row crop. And some of these other ones like grasslands and roads and water and forest, each of those make up 3% each of the watershed. Again, so row crop makes a very large percentage of the land use within the watershed. Excuse me. Another thing that we look at is the topography of the watershed, and for the watershed of Hickory Grove Lake, it's pretty flat. The average slope is 3%, and 90% of the watershed has a slope that ranges between 0 and 5%. Again, so it's relatively flat with us, with some gently sloping topography, mainly in these areas close to the lake where there's some defined channels. All right, so an assessment of Hickory Grove, we kind of asked the question, well, what's wrong with Hickory Grove? And a couple of things. Water clarity is the issue, and that results from sediment that are suspended solids in the lake. The other issue is algae, which results from excess nutrients in the lake, specifically phosphorus and nitrogen, which can also create clarity issues within the lake itself. So determine, how we determine if an impairment exists or not, we go through an analysis and collection and analysis of water samples from the lake. So this little disc here represents and shows where we collect our samples from Hickory Grove Lake. They're typically near the spillway, and it's the same location every year. It's generally going to also be at the deepest part of the lake. Those samples are collected during the recreational season, which is March 15th through November 15th, with most of the samples being collected between Memorial Day, which is late May, through Labor Day, which is early September. And those samples are collected annually. So we get out on our boat to go to the sampling point. We collect our samples and then send them to the lab. And the lab does an analysis on them to determine the chemical composition of the lake. We're looking for things such as phosphorus, nitrogen, chlorophyll, which represents algae, dissolved oxygen, E. coli, and other chemicals within the lake itself. Another important thing that we look at in determining the water quality is the clarity. Sometimes you can look at the lake and it might have a little look green, which would indicate algae, or it might have a brown or reddish tint, which would indicate a sediment load within the lake itself. And one way we determine the clarity is we use a device, this circle here called a Secchi disc. And the Secchi disc is about 30 inches or 30 centimeters in diameter. It's painted black and white in alternating quadrants. The device is attached to a tape measure, and it's lowered into the water until you can't see the disc anymore. And at that point, the measurement is taken, and that measurement becomes our Secchi depth. As a comparison, Hickory Grove Lake has a Secchi depth of approximately 1 meter or 3 feet, while East Okoboji Lake up north has a Secchi depth of about 5.5 to 6 feet. So there's a considerable difference between the two as far as their clarity and visibility within the lake itself. Okay, so once we've collected our samples and done the analysis, we want to plot them to see how they, what trends might exist, or how they relate to water quality. And so here in this graph, we've plotted our year across the bottom, across the x-axis, and our y-axis, we're going to plot what we call the TSI value. And the TSI value is, I guess the short answer for it is a trophic state index, but it is a classification system designed to measure the biological activity within a water body. And so the higher the number, the more biological activity exists, and the lower number, the less biological activity that exists. I've put two lines here, a red and a blue. Now the red line represents our impairment limit. We want to keep our TSI values below 65. So as we look at that data, if our TSI values exceed 65, then the water body becomes impaired. Now, this blue line represents a TSI value of 63. Once a water body has been impaired, in order for it to be removed from the impaired waters list, the TSI value must drop below 63 for an extended period of time. It can't just show up 1 year and be below 63 and taken off. It has to stay on below that 63 value for an extended period of time. The other thing that I'd point out here is that with these first couple of graphs, we're looking at a 5-year median TSI value. And so, for example, 2016, the 5-year median values would be the data collected from the 2012 through 2016. So that would be the 5 years. So with that data, we're going to go ahead and plot it. And we have the purple squares represent our TSI values for TP, or total phosphorus. The blue diamonds is our TSI values for Secchi depth, and our green triangles are TSI values for chlorophyll, which is a representation of how much algae is in the lake. And if we go back again, this is a 5-year median value. So if we go back in 2008, we can see with our chlorophyll values that the values are rising or a trend upward till we hit the year of 2014, where we reached a TSI value of 65, and that's when Hickory Grove Lake was placed on the impaired waters list. And since 2014, we kind of see that it's kind of leveled out a little bit. Hasn't begun to drop yet down towards that TSI value of 63. And the green line is just a trend line, and it shows from 2008 that the trend for our chlorophyll, our TSI chlorophyll values is increasing. Now I wanted to show another graph, and this is the same information, our yearly, the years the samples were collected, our TSI value, but instead of a 5-year median TSI value, we're just going to look at the annual median value. So, the annual median value for data or samples collected in 2010. Again, we have our Secchi depth, our chlorophyll, and our phosphorus. And we see on our trend line, it continues to go up from 2010. We see in 2014 and 15 that the TSI chlorophyll values exceeded 65, but we also see in 2016 where that chlorophyll value dropped down even below the 63 value, down to 60. And the hope is that the trend, this downward trend, continues on into the future, because as I mentioned earlier, for the water body to be removed from the impaired waters list, that 5-year median value has to drop below 63 for an extended period of time. So with this data, it shows that there is some improvement happening and going on within Hickory Grove Lake. It just needs to continue on for an extended period of time. So what is a Tmdl? And Jeff explained it a little bit with that tipping point and his donkey and his cart, but I guess to me the definition of it is how much pollutant can a water body assimilate, or can it take in and still meet water quality standards. And as we develop our Tmdl, we look at several different things. We look at our target. What is our target, our pollutant target that we're looking to isolate and remove and reduce from the watershed. And then we're going to look at sources. What are the main sources? And Jeff touched on that just a little bit. There's point and non-point sources. And then we're going to do the math part of it. We're going to look at the equation, the Tmdl equation, and determine what is the actual value or mass or concentration of that pollutant that the water body can receive and still meet water quality standards. And then we look at an allocation, basically how that loading is divided up, or the pollutant is divided up within the individual sources. All right, so in this case, our target is phosphorus. Phosphorus leads to algae. It also is tied to sediment, which creates clarity issues. We talked about that a little bit within the water, within the lake itself. And phosphorus is going to be transported either through sediment or runoff and through groundwater flow. So our objective is to reduce the sediment laden runoff that goes into the lake, stop it from getting to the lake as much as possible. So the sources, and Jeff talked about, and I'm going to talk about just a little bit more here. There's two sources. There's a point source and a non-point source. Our point sources would be like a wastewater treatment plant. Got a little ahead of myself there. The point sources that are a wastewater treatment plant, and that's probably what I see most of the time throughout the state, is that wastewater treatment plant as being a point source, but it's something that needs an NPDES permit. So all point sources require a permit. And we have no point sources within this particular watershed. So in our analysis, we don't have to consider this part or this source in our evaluation because they don't exist within the watershed. The other source is the non-point sources, and that would be anything that does not require a permit. That would include, land runoff, direct deposition of manure in streams from grazing animals, failing septic tanks, stream bank erosion, and so on. And there's just a list of a handful of non-point sources. Again, the non-point sources do not require a permit, while point sources do require a permit. So kind of a brief summary here. Our target is phosphorus. Our target pollutant is phosphorus. Our sources are going to be non-point sources. And so the next thing we look at is the equation, or the Tmdl equation, or the math associated with it. And it's a pretty simple equation. It's our total maximum daily load is equal to the summation of our waste load allocations plus the summation of our load allocations and a margin of safety. And that probably requires a little bit more explanation, because point sources receive waste load allocations. They have a permit that limits the amount of a pollutant they can discharge, so that it's a waste load allocation. So if we had point sources, we would sum all those. If we had point sources within the watershed, we would sum up all the phosphorus that those point sources would discharge and put that into the equation. But since we don't need to consider this. This is 0. So then we're left with a non-point source and a margin of safety. And the point sources would be just a load allocation. So through our analysis, we have determined that the total maximum daily load of phosphorus that the Hickory Grove can receive is 3,432 pounds of phosphorus per year. And so when we look at that in the equation, we're going to take 10% right off the top is our margin of safety. And whatever's left over would be our load allocation. That would be the allowable phosphorus load that would come from those non-point sources. We look at that in a different way. I guess the one thing that right now, as we've gone through our analysis, what is coming into Hickory Grove on an annual basis is 5,529 pounds per year. And our goal and objective is to get down to 3,432 pounds per year, which translates into a 30% reduction of total phosphorus to the lake. All right, so we've looked at those first three bullet points. The next thing we look at is allocations, how that phosphorus is divided up amongst the non-point sources. And so as we look at that, as we said that the land use, 85% of it is row crop. And so if we look at where the phosphorus is coming from, it would make sense that most of it's going to come from our row crops, with roughly 87% of the phosphorus load coming into Hickory Grove Lake is from the row crop, and approximately 13% of that phosphorus load is coming from all other sources. And so and as I said, it just makes sense that with a high percentage of land use being row crops, that a higher percentage of the phosphorus would come from the row crops as well. So with an implementation plan, we've determined the existing load, and then we want to look at what we can do to improve water quality. And so the implementation plan looks at possible solutions, best management practices. It encourages local participation, and again, allows and encourages for future monitoring. So some of the best management practices that can be implemented, I guess there's three types of best management practices, and that could be implemented, three categories. One of them would be land management, which would be prevention. How do we keep the phosphorus or the pollutant at its source? We don't let it get beyond its source. And that provides this kind of practice provides benefit to both soil and water quality. Here are a few examples of land management practices. A no-till, a conservation till, cover crops, perennial strips, manure and nutrient management. Here's one method of the no-till farming. We can see the soybean crop planted over last year's corn crop. This is a way of planting and growing crops without disturbing the soil through tillage, and by not disturbing the soil, it stays in a tight matrix, which reduces erosion and so prevents erosion and helps soil health. It increases organic matter within the soil itself. Yeah, another practice is structural or mitigation. We intercept the pollutant during transport. If it gets off the land, then we want to, again, intercept it, trap it before it gets to the lake. And some of the examples of these, riparian buffer strips, saturated buffer strips, and a sediment basin. So here we have a sediment basin. What happens is is as water comes down the channel, it hits the sedimentation basin, and it slows any of the energy that the water had, slows it down enough that it deposits all the sediment within the basin itself. And these can be constructed prior to the lake, and that would prevent that sediment from reaching the lake. And the last practice is in-lake remediation, fixing the issues in the lake, at the lake itself. And some of the examples of these would be fisheries management, shoreline stabilization, and targeted dredging. And at this, I have to add here that Story County has been pretty proactive. Last year, they lowered the lake, and they began a lake restoration project where they have implemented all three of these practices. As they've lowered the lake, they've removed carp, which consumes plant life within the plant, also takes up phosphorus. The fish stir up the bottom, which again resuspends any sediment and phosphorus off the bottom. And so they've implemented all three of these already. And so here's a picture of targeted dredging, and this is an actual picture from Hickory Grove Lake at the east end of the lake. They have a sedimentation basin that they, as part of their lake restoration project, have removed the sediment from that basin, as well as they have targeted specific locations within the lake itself to remove sediment. And so again, Story County's been very proactive in working on water quality improvement. So our next steps then are to continue to monitor, continue to assess the practices and BMPs that have already been implemented, and then to encourage local efforts, and to allow DNR to be a resource for them and technical assistance as they go through this process. So with that, this is the end of my part. If you have questions or comments, feel free to send them to myself, particularly if you have some questions regarding the water quality improvement plan or technical questions about it. You can email those to me at james.hallmark@dnr.iowa.gov. Or if you have other comments, you can send those to Jeff. He needs to have those by the end of our public comment period on February 15th. And you can send those comments to him at jeff.berkus@dnr.iowa.gov. And thank you for your time.